Okay. So we're going to talk today about something new. Okay. This is the when they redid the College Board redid the AB and BC courses over the last year. You guys are the first ones through the new course. This is the one new thing they added. Okay. The other thing they did was they took it down from 5 answer choices to 4. Yeah, that's good for you guys. Yeah. I guess it isn't statistically significant to have that extra answer choice, so they just get rid of it.
So last year they had 5 options with multiple choice.
This year you've only got 4. Now, when we were going through some of the review stuff out of the newer stuff last year, they were already doing this rule. So, oops, sorry. It's not okay. So, let's first of all talk about how to pronounce it. Is there an S in the middle of it? No. It's Hopital. Okay, Hopital. All right. And you will see me tend to abbreviate this with just this. Okay. When I do Hopitals Rule, I'll tend to write that next to it. You don't have to. It just that's my habit, so you know what happened. Okay. All right. So we're gonna first of all talk about indeterminate forms, and then we're gonna talk about the Hopitals Rule. All right. So, indeterminate forms. My thing didn't upload right. Okay. These are some things that we can't determine. When we get 0 over 0, we really don't know what that is. It's not 1. Same with infinity over infinity, and I don't know why these didn't type in there. So you might want to put these out in the left-hand column. I know there's not a spot for them, but I would write indeterminate forms and write these down. 0 to the 0 is indeterminate. 1 to the infinity is indeterminate. There's one more. Let me think about what the other one was. Thought I'd fixed the PowerPoint, but... what else? Infinity to the 0, and then infinity minus infinity is also indeterminate. So if you get any of those situations, that's when we have to apply this rule. Okay. Ladies, do you want to take your tests? Okay. I'm going to send you guys out. Alright, while I'm getting them set up, go ahead and write those 2 down, okay? Okay. You ready? You want to finish your test? Yes? Okay.
Did you guys read it? No. I have fruit snacks. I'm just going to send them right there for $1. Or in our English class. Are you going to do that for your basketball game today? So I'm going and I'm helping sell my tickets, and I'm going to set up the tickets or the fruit snacks right next to the tickets.
Do that.
I just said that, so I'm doing it. And plus I'm selling and working.
I'm doing it today.
Are you working?
Yeah.
What time?
Same time as you?
Are you going to track practice today, Delon?
What's that?
Oh, you're not going to do track? Are you serious? Oh, you can't, huh? Why not? Her mom will probably will. Why not? You did soccer.
Okay, we ready?
But now.
Okay, so Hopitals Rule has to do with limits. Okay, so we're trying to take the limit of something as it approaches a value, and it doesn't. It could be C, it could be infinity. So whatever that number is there, if we get one of these indeterminate forms, that's when you do Hopitals Rule. And what Hopitals Rule says is that if this limit comes out to one of those indeterminate forms, take the derivative of the top and the derivative of the bottom separately, not quotient rule. Okay. So separately, and then see if that limit works. And if that one doesn't work, do L'Hopitals rule again. And then do it again until L'Hopitals rule works and you get a limit of something. Okay?
It has to work no matter what.
It's going to end up working, yeah.
If it asks you, you have to answer it.
Yeah.
Oh, wow.
Yep. And technically, we could use L'Hopitals rule all the time, okay? But we tend to use other things when we can, all right? So first of all, I kind of cheated and gave us the indeterminate form there. But let's talk about why it's indeterminate, all right? So if I put a 0 in here, I would get e to the 0 power. What's e to the 0 power? Anything to the 0 power is 1, right? So I'd have 1 minus 1 over 0. 1 minus 1 is 0. So notice, we have to get a 0, 0. If it had been like 1 over 0, that's undefined. That's not indeterminate. Okay, so there's a difference. So we do have an indeterminate form. That means I'm going to use L'Hopitals rule. So when I use L'Hopitals rule, I just put that next to it. Again, that's Mrs. Ballard's notation. That isn't anybody else's. Okay. So I'm going to do the limit as x approaches 0. And I'm going to take the derivative of the top and the derivative of the bottom. Okay. So what's the derivative of e to the 2x? E to the 2x with what out front? The 2. Good. And then what's the derivative of the x? 1. So now I'm going to try to do direct substitution on it again and plug in. So if I plug a 0 in, what's 2 times 0? 0. E to the 0 is 1. 1 times 2 is, so it worked this time. So the limit of that is 2. Okay? I couldn't show it to you earlier because a lot of these have the e and the natural log and all of that stuff in it. Okay? So that's why we didn't learn it when we learned limits. So it doesn't hurt to go back and revisit limits. All right, we good with example 1? All right, example 2. So let's talk about what this one would look like in indeterminate form. So if I plugged in it, notice I'm going to infinity this time. So the natural log of infinity over infinity. What's the natural log of infinity? Isn't it that? And I can't tell what infinity over infinity is, okay? Maybe it's infinity, I don't really know, but so we consider it indeterminate, okay? So I am going to take the derivative of the top and the derivative of the bottom. Okay, so what's the derivative of the top? 1 over x. I haven't taken a limit yet, so I've got 1 over x over, what's the derivative of the bottom? 1. So really what I have is the limit as x approaches infinity for 1 over x. Okay, I'm going to go ahead and sub the infinity in now. What's 1 divided by a giant number? 0. Okay, so not so bad, right? Not so bad for the day before break. Okay, we good with 2? All right. So number 3, let's check for our indeterminate form to begin with. Okay, so I'm going to plug my infinity in there over e to the negative infinity, right? Because it was a negative infinity. So my numerator looks like it's going to be infinity. My denominator probably is going to be infinity too, right? Because e to infinity is infinity. So do I have an indeterminate form? Yeah, so I have to check for that even though Mrs. Ballard has told us in the notes what it is, okay? All right, so let's try L'Hopitals rule. So the limit as x approaches negative infinity. What's the derivative of the top? 2x, good. And then the derivative of the bottom is what? Negative e to the negative x, good. All right, so let's try plugging into that. I would get 2 times infinity over negative e to the negative infinity, right? So don't I still have infinity over infinity? We all agree with that? Okay, so that means I'm going to do L'Hopitals rule again. I'm going to keep going with L'Hopital until I get something that works. Okay, so what's the derivative of the top? 2. And then negative e, not negative e. E to the negative x, and then that negative and this negative, what's going to happen? Yeah, it's going to cancel to positive. All right, let's try putting in the negative infinity now. So I get 2 over e to the negative infinity. What's going to happen with the double negative? Positive. E to the infinity is... it's infinity, right? And 2 divided by infinity is 0. Do you see how it was having that x in the numerator that I had to wait till I got rid of that x, and then it all fell out? That happens a lot. Okay, so it's just kind of the pattern with L'Hopital. The answers will not all be 0. Okay? Yeah, take the power. Oh, you guess you don't really need to pass this time of day, do you?
Do we need to, are we supposed to have the indeterminate forms in our notes already? Or do you guys write them down?
I would probably put them in the left-hand column. Because they're not there already, are they? Even though I said recall, they're probably not there. Okay? Yeah, it was... because I grabbed this lesson from BC. So. Alright. Okay, let's look at this one, example 4. Okay? We're going to crank through all of this in one day. Okay? So, we have... I'm going to rewrite this a little bit. Okay, I'm going to rewrite it before I try to look at it. Because it doesn't look like I have L'Hopital at this point. Okay? Well, actually, I could look at it as I did. Actually, if I did plug in, let's plug in the infinity real quick. So you can see where the L'Hopital is coming from. So if I plug in the negative infinity. Okay. This... oh, no, I'm wrong. Don't do it there. Let's rearrange it first. I'm looking back at my notes again. Okay. So I'm gonna rearrange it. This guy's not happy where he's at, right? So let's move him downstairs. Now let's see what happens if I put in... I could break it up like this, couldn't I? It's the same thing. Okay, now if I put in that negative infinity times the square root of negative infinity. What have we seen that become every time? It's infinity, isn't it? So what's 1 over infinity? 0 times infinity, right? So do you see how the indeterminate form's a little bit different this time? But it's still indeterminate. Okay, so I'm going to go ahead and I'm going to take some derivatives. This guy is really the same as saying x to the 1/2. So I'm going to apply L'Hopital's rule. The limit as x approaches negative infinity. So what's the derivative of this numerator here? X to the... we're subtracting 1. Negative 1/2 over... what's the derivative of e to the x? E to the x. Is the x to the negative 1/2 happy where he's at? No, so I'm going to bring it downstairs. And technically this 2 could get thrown downstairs as well. Limit as x approaches negative infinity. So we've got 1 over 2 square root of x e to the x. Now let's try putting in the negative infinity. So we have 1 over 2 square root of negative infinity e to the negative infinity. What's in your denominator going to be? It's going to be negative, and it's going to be infinity somehow, so it's going to overall be 0. Alright, I'm going to make it uglier. Yeah. If you plug in whatever your limit's approaching, the past few have been infinity, right? Oh, I said to do, I switched it to positive infinity, so I didn't get a negative under the radical sign on this one when I was doing it before. So I guess we could do that, but it's not going to matter at this point, right? Okay, let's look at the next one. The next couple are a little bit uglier, okay? The next one's kind of long, alright, but we can handle it. Alright, so they're saying the indeterminate form is 0 to the 0, so let's talk about that. If I put a 0 in, if I put sine of 0 to the 0 power, what is the sine of 0? It's 0, right? So do you see how the indeterminate form popped up there? Okay. So we know we've got the indeterminate form. I'm going to try to do L'Hopital. But with this particular one, it's difficult to deal with that exponent. So when we see that exponent, the way we get stuff out of the exponent is to use logs. Okay? So I'm going to start by rewriting it as y equals something, because I can't use logs unless I use a y equals. sine x to the x. All right, I want to get that this variable out of the exponent, so I'm going to take the log of both sides, or the natural log of both sides. Limit as x approaches 0 from the right, sine x to the x. And I'm going to do a lot of things in one step at a time so you guys don't get lost. All right. Now, there's something weird that we can do that we have never seen before. But technically this natural log can get put inside the limit. Okay, so I'm gonna squeeze that operation inside the limit. Okay, we're allowed to do that. We've never seen that before. Okay, it's not really distributed, I'm just kind of rearranging. Okay. So I've got the natural log of sine x to the x. Oops, I don't need that last parentheses. Make that look like a sine. There we go. All right. Now, what am I allowed to do with this x now that I have a log in front? Move it to the front. Okay, so we've got the natural log of y equals the limit as x approaches 0 from the right of x natural log of sine x. Okay. And we really don't have a L'Hopital situation set up there. What we have is some kind of weird product rule going on, so I'm going to introduce something weird, okay, to get rid of this x up here. I'm going to pretend like there's a denominator of 1 there. And again, it's a technique. You don't see this in every problem, but I want to make sure if you see it in the homework, you're ready for it. So I'm going to choose to multiply everything by, I'm going to multiply by this. Looks weird, right? What I'm trying to do is introduce it into the introduce a denominator. So if I introduce 1 over x divided by 1 over x, it's like multiplying by 1. Okay? What it then happens with this x and this x? They cancel. So basically I've rearranged where that x is going. So I have the natural log of y equals the limit as x approaches 0 from the right of the natural log of sine x over 1 over x. All right. And I haven't really done L'Hopital yet, right? I've just rearranged a whole bunch of algebra. I know I need to do L'Hopital. Yes, Caesar.
How did you get that 1 over x?
How did I get the 1 over x?
Natural log is.
Here?
You just found the derivative.
I haven't done a derivative yet. Okay? I introduced it because in order to do L'Hopital, we really need a denominator. So the way to artificially create the denominator was by multiplying by 1 over x and 1 over x, because that got rid of it here. So I don't have a funky product rule. Okay? All right. I'm going to go ahead and we're going to do Hopitals Rule. Okay? So I'm going to put my work up here. So now I'm finally going to take the derivative of the top and the bottom. I'm keeping the natural log of y, the natural log of y. Okay? I'm only doing Hopitals Rule on the right side. Okay? So, what is the derivative of the natural log of sine x? 1 over sine x, and then what are you going to get for your chain rule? Cosine x. All right. Over, what's the derivative for 1 over x? Be careful. Well, 1 over x is the same as x to the negative 1. Remember, I have to grab this to the front and subtract 1 off of it. So don't you get negative 1 over x squared. Good. You got to be careful with the 1 over x, right? Because we're not integrating it. We're taking the derivative of it. Okay. So now let's see what we have left here. Again, we're going to use a bunch of fancy algebra. What's cosine over sine in trig? Cotangent. Okay, x. And then I still have this funky thing here, right? Let's see if I can simplify a little bit more and make it look... I'm gonna do some weird trig simplifying here, okay? Cotangent is the same as 1 over tangent, right? Alright, and then this thing here, if I was to get it out of the denominator, couldn't I flip and multiply? So if I looked at cleaning that up, I don't have to write this line, but now I've got negative x squared over the tangent of x. And again, if I tried to sub in my... I lost my limit, didn't I? It was supposed to still have the limit. I totally lost it when I wrote it here. Limit as x approaches 0 from the right should be in front of all of those. Limit as x approaches 0 from the right. Limit as x approaches 0 from the right. Okay. So I am going to plug in. I'm gonna do L'Hopital again, because if I try to put 0 in there, I still get 0 over 0. Okay, so I'm gonna apply L'Hopital one more time. So the natural log of y equals, what's the derivative of the top? Negative 2x over what's the derivative of the tangent of x? Good, secant squared x. All right, now let's try putting in the 0, okay? So I'm sort of out of space. I'm gonna try it. Let's see if I can squish it right here, okay? You guys out of space too? Okay, sorry, this one's long. I'm gonna have to get more space in there. I'm gonna make this one the last one for today, and we'll do the other two when we get back from break, okay? All right. All right, we'll find some sticky notes and put them in there, okay? All right, so the natural log of y equals, so we're plugging in. What do I get? So if I plug in 0 for the numerator, don't I get 0? What about the secant of 0? What's the secant of 0? 1, right? And then 1 squared would be 1. So I know that this whole thing is actually 0. How do we get rid of the natural log on the left side? Exponentiate it. E to the 0. Okay, so that's gone. So we've got, and anything to the 0 power is? 1! That one was long. All right, I'm going to stop there, and we'll do the other two, but when we get back from break, if we need to add some sticky notes in there, we will, okay? So here's my goal, you guys. My goal is to make sure that we're testing by Thursday when we get back, okay? So I will try to, hopefully before the end of today, I'll put some multiple choice and hints out there so you have the break to work on it. Before the end of the day, there will also be more Khan Academy extra credit related to the last test, okay? So look for that. All right. Before I adjust the homework, let me talk about fruit snacks for a minute so you guys know what the deal is there. Okay. I know we came and got them yesterday, but let me